Hey everyone, my name is Stanley, and today we're going to be talking about measures of center and measures of variation. So what's a measure of center? Well, it's a value that attempts to describe a set of data by identifying the central position of a data set. Now keep in mind, there's a bunch of ways to actually determine a center, in quotation marks, of a data set, and that's why our most common measures of center are the mean, the median, and the mode, which is right here. Let's talk about the mean. The mean is the average of the numbers in the data set. In order to calculate this, you add up all of the numbers in the data set and you divide by how many numbers there are. For example, let's say we have this data set. We have all of these numbers. So what we do is add everything together. 1 plus 6 plus 12 plus 63 plus 32 plus 9 plus 45 plus 10. And that's all equal to 178. And how many numbers are in the data set? Well, there's 1, 2, 3, 4, 5, 6, 7, 8. So the mean is 178 divided by 8, which is equal to 22.25. So that's the mean of this data set. Let's look at median. The median is the middle of a sorted list of numbers. So in order to calculate this, we arrange all the numbers in the dataset in numerical order, and then we have to find the middle number. So let's say we have a dataset that looks like this. In order to find the median, let's arrange everything into numerical order let's say from smallest to biggest. So we see that 3 is the lowest. So let's put 3 down and cross it out. We know that 6 is second, so let's put 6, then 7, then 18, then 19, then 23, 23 again, 25, then 54. Now I just arranged the entire data set in order. In order to find the median, we have to find the middle number. A good trick to do this is by crossing out the values. We will cross out both the beginning values and the end values. Every time you cross out a beginning value, we'll cross out an end value in order to basically make it smaller and smaller and smaller until we hone onto a single value that we can say is our median. So let's start. Let's cross out this first number, and then we'll cross out the last number. Now we have a smaller set that we can look at. Let's do it again. Crossing out the second number, we'll cross out the second last number. Now we have an even smaller data set to work with. Let's keep doing that until we have one last number left, and that is 19. So in this case, 19 is the median, or the center of this data set. But keep in mind, this data set has 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers in the data set, which is an odd number. That's why we were able to hone onto one single number in the data set. But what if the data set had an even number of values? Let's look at an example. This is basically the same data set as before, but I added an extra number to make it 10 values in the data set. So let's do the same thing. Let's arrange everything into numerical order. 7, 18, 19, 23, 23 again, 25, 54, then 90. Now, let's use that crossing out method again. As we try to hone onto a single number, watch what happens. We have 2 numbers left, but we have to cross out the beginning one and also cross out the end one. But once we cross these 2 out, there's nothing left. So in this case, because the dataset has an even number of values, what we do is that we find the average between these 2 last numbers that we crossed out. So in order to find the average, you add them up and divide it by 2 because there's only 2 numbers there. And that is 21. And therefore, 21 is the median or the center of this data set. Finally, let's look at mode. Mode is the number that appears the most often in a set of numbers. In order to calculate this, we'll count up how many of each number there are, and we'll see which number appears the most or has the highest frequency. So let's look at an example. According to this data set, we can see 21 appears 3 times. So we know that 21 will appear 3 times. We can see that 3 will appear 2 times. So we know 3 goes 2 times. We can see that 7 appears 2 times. So let's write that down. We can see that 18 only happens once. 19 only happens once. And 54 only happens once. Now it's clear, 21 appears 3 times, and that's more times than any of the other ones. So therefore 21 is the mode, as it appears the most frequently. So now that we covered the measures of center, what about the measures of variation? Well, those are values that are used to describe the distribution of the data instead of the center. Some of the most common measures of variation are the range, standard deviation, and quartiles. Let's look at the range. The range is the difference between the highest value and the lowest value. In order to calculate this, we'll subtract the smallest number from the biggest number. Let's look at an example. Looking at this data set, we can easily tell that 103 is the largest number, so let's keep that in mind. And by looking at it again, we can see that 2 is the smallest number. So in order to find the range of the entire data set, we do 103, which is the largest number, minus the smallest number, which is 2, which is 101. And that is going to be the range of the data set here. What about mean standard deviation? Well, mean standard deviation is a little complicated. It is a measure of how much a data set varies, and more specifically, it is the average of how far each data value is to the mean. That definition may be a little bit confusing, but it is much easier to visualize when I do the example. So in order to calculate this, first we find the mean of the data. This value is extremely important because we're going to be comparing all the other data points to that one value. So once we have that mean, we then find the absolute value of the difference between the data value and the mean. So we will actually go through each data value and see how far it is away from the mean, and we'll write that somewhere else and keep track of it. After you do all of that for all the data values, and we have this set of numbers, we then find the mean of all of those values, and that will be your mean standard deviation. So let's look at how you do this. Let's say we have a data set of this. So in order to find the mean, we'll add everything up. 6 plus 5 plus 3 plus 18 plus 14 plus 8 plus 5 plus 12 plus 7 and plus 12. And that all equals to 90. And how many values are in the data set? Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the mean is 90 divided by 10, which is 9. But we're not done yet. Now that we have the mean, we actually have to look at each value of this data set and see how far away that is from this number here, 9. And we should probably keep track of it in another space. So let's look at 6. 6 is 3 away from 9. So let's just write it up there. And we have to do this for each data value. So let's look at 5. 5 is 4 away from 9. 3 is 6 away from 9. 18 is 9 away from 9. 14 is 5 away from 9. 8 is 1 away from 9. 5 is 4 away from 9. 12 is 3 away from 9. 7 is 2 away from 9. And 12 is 3 away from 9. Now that we have this data set, we now have to find the mean of this. So let's add everything up here. 3 plus 4 plus 6 plus 9 plus 5 plus 1 plus 4 plus 3 plus 2 plus 3 equals to 40. And since there's 10 values here, the mean of this entire data set is 40 divided by 10, which is 4. And that is the mean standard deviation. Now this all might sound a little bit confusing, so I'll just go over what I just did. The first step to finding the mean standard deviation is finding the mean of the data set itself. And the mean is 9, we found here. And now we found how far each data value is from 9, which is the mean. So all of these represent the absolute value of the difference between each data value and 9. And then the average of all of these is the mean standard deviation. So really, the mean standard deviation is the average of how far away all these numbers are from its mean. In other words, each data value is on average 4 away from 9, or the mean. Let's look at quartiles. So quartiles, in the name, divides the data into 4 segments. There are 3 points in the data set that marks these divisions: Q1, Q2, and Q3. Keep in mind that Q2 is the median. So let's say that this bar was a data set. Quartiles will divide this into 4 sections. Q2 is the middle, Q1 is the left, and Q3 is the right. In order to calculate all the quartiles, let's first find Q2. In order to do that, we calculate the median to find Q2. Then, after we know the median, we separate the data into 2 halves, the upper half and the lower half. Looking exclusively into the lower half, we can find the median of that to get Q1. And then looking at the upper half, we'll use the median to find Q3. Let's look at an example on how to actually do this. So let's first find the median of all of these values. In order to find the median, we have to arrange everything into numerical order. So let's do that. 1 is the smallest, 2 is next, then 3, then 5, then 5 again, then 8, then 12, then 17, then 21. Now that it is all in numerical order, we can find the median by crossing out the front, then the back, the front, then the back, the front, then the back, the front, then the back. We can find that the median is 5. So that is actually quarter 2. So let's just erase all these cross marks. Note that there are 4 values to the left of Q2 and 4 values to the right of Q2. This will be our lower half, and this will be our upper half. So let's find the median of the lower half, which is here. The median is crossing out 1 and 5 and 2 and 3. Oh no, we don't have a value that represents our median. So what we do is average the 2 numbers that the median should be between, which is 2 plus 3 divided by 2, which is 2.5. And that is Q1. And now let's look at the upper half. Let's find the median. Cross to 8, then cross to 21. You cross to 12 and then cross to 17. And the same problem happens. So what we do is find the average between 12 and 17, and that's equal to 29 over 2, which is 14.5. And so that is Q3. Now we have found all of the quartiles. Another important term that you might need to know is the IQR, or the interquartile range. What the IQR really is the middle 50% of the data. In order to find that, we just do Q3 minus Q1. And in this case, it's 14.5 minus 2.5. And so this is just 12. So IQR is 12. So now let's look at outliers. Note that outliers are not a center of measure or a center of variability. It's just an extreme value in a data set that is either much larger or much smaller than all the other values. So let's look at an example. Looking at this data set, we can easily tell that 50 is just way larger than all the other numbers. So that's why 50 is the outlier. So what would happen if we got rid of 50? Well, then the mean of the data set would dramatically decrease because 50 had been dragging the mean or the average of the data set much larger than it actually is without the 50. By eliminating a really big number, the average of the remaining numbers are going to be much smaller. So by eliminating this outlier, the mean will decrease. So that's really it for centers of measure and centers of variability. I hope you enjoyed, and make sure to check out all the other videos made by us. The links to the classwork and the homework are in the description below. Bye everyone!